Acids and alkali, they are different, two different personalities, and you're gonna find out what they're all about if you wanna learn some chemistry. Now the first thing you're gonna get straight in your head, acids turn blue litmus paper to red. They react with metals and carbonates. They neutralize with alkalines, then they taste sour. Now alkalis are different from acid, it's true. They will turn red litmus paper to blue. They neutralize acid and feel slippery on the skin. They taste kind of bitter, they are alkaline. Acids and alkalis, they are different, two different personalities, and you're gonna find out what they're all about if you wanna learn some chemistry. Now the first thing you're gonna get straight in your head, acid turns blue litmus paper to red. They react with metals and carbonates. They neutralize with alkalines and they taste sour. Now alkalis are different from acid, it's true. They will turn red litmus paper to blue. They neutralize with acids and feel slippery on the skin. They taste kind of bitter, they are alkaline. Boys and girls, welcome to Acids and Alkalis Secondary 2 Science e-learning module. Today, we're going to learn the type of chemical changes, interactions between metals. At the end of this section, you should be able to answer the following questions. What are the common reactions involving acids and alkalis? How does neutralization take place? How can we differentiate between acids and alkalis? For a start, let us look at one example. Antacids are usually prescribed for gastric pains. Gastric pains are felt when too much gastric juices are produced in the stomach. Antacids react with hydrochloric acid found in the gastric juice to form a harmless product. This provides relief for gastric pains. Let's look at a video on antacids.
Ever wonder what's going on inside your stomach when you're not feeling so good? Well, I went to Imagination Station to find out. You may remember that old slogan, pop, pop, fizz, fizz, oh, what a relief it is. We're going to find out all the science behind why antacids make you feel better. So I've got my extreme scientist here at Imagination Station, Nicole. Hi, Nicole. Hi. Tell us what we're going to do today.
All right, well, again, we're going to talk about this chemistry that goes on in your stomach.
Okay.
So to do this, chemistry in your stomach is acids and bases. So the first thing we need is this is what's called an acid-base indicator. All this is a chemical that changes color depending on whether something is an acid or a base.
Okay. So what makes us feel bad? Is it something that's acidic?
When you get too much acid in your stomach, it's usually what makes you feel bad. So right now we have just our water. And now you see it's this really dark color.
Yeah.
That comes from the water being slightly basic. But we know our stomach isn't basic. Our stomach is acidic. So what I have here is just some hydrochloric acid.
This is adding some.
This is acid.
Oh,
Look what happens.
Oh, that's cool.
Now watch what, okay, so now it is an acidic solution. That's what's normally in your stomach.
Acid
But let's say, you're at a party at the weekend, you eat a little too many spicy tacos, you're not feeling so well.
Yeah.
So we're going to dump in an acid.
Okay.
Now what we're using is something called milk of magnesia.
Okay.
It's magnesium hydroxide, which is a weak base. So we're going to dump it in and watch what happens to our color.
Oh, wow. Yeah, okay.
We go right back to basic, right? It takes it out.
Yeah.
Now the really cool thing about antacids, such as milk of magnesia, is they actually make what's called a buffer, which means it's something that can react with either an acid or a base. So I'm going to put more acid in. Watch, it's going to turn pink, but it's going to turn right back. It's going to turn right back, and we could keep doing this and keep doing this, which is why once you've taken that antacid, it keeps working. You don't have to take another antacid every.
Well, so what are acids? Acid is a substance that produces hydrogen ions, H+, when dissolved in water. It is hydrogen ions that are responsible for the properties of acids. The role of water in acids are as follows. Acids are covalent compounds. Acids only show the properties of acids when they are dissolved in water. Dissociation of acids in water or dissolving acids in water produces hydrogen ions, or we call it H+. Now, acids are found in many things around us. Some are found naturally in living things, while others are made in industries and used daily for various purposes. Can you think of some examples of acids and their uses in our daily lives? Well, these are some common acids in our daily lives. We have vinegar, we have the orange juice, the lemon juice, which contains the citrus acid, and carbonic acid that is found in carbonated drinks. Acids react with other substances to produce chemical changes, which mostly benefit us. For example, for this car, the sulfuric acid is used in car batteries. Hydrochloric acid is used to remove rust on iron and steel. Acids react with some metals. Decorative patterns can be crafted onto metal objects by acid etching. This process makes use of the reaction of acids with some metals. Firstly, a metal plate is covered with wax. After that, the wax has hardened. Parts of the wax are carved away in a decorative pattern. This leaves the metal beneath the wax layer exposed. Acids are found in many things around us. Some are found naturally in living things, while others are made in industries and used daily for various purposes. Can you think of some examples of acids and their uses in our daily lives? Well, these are some examples of acids in our daily lives. We have the vinegar, the citrus, well, these are some common acids found in our daily lives. We have the vinegar, the orange juice, the lemon juice that contains citric acid, and carbonic acid found in carbonated drinks. Acids react with other substances to produce chemical changes, which mostly benefit us. For example, for this car, the sulfuric acid is used in car batteries. The hydrochloric acid is used to remove rust on iron and steel. Acids react with some metals. Decorative patterns can be carved onto metal objects by acid etching. This process makes use of reactions of acids with some metals. Firstly, a metal plate is covered with wax. After the wax has hardened, parts of the wax are carved away in a decorative pattern. This leaves the metal beneath the wax layer exposed. The metal plate with wax is then dipped in acid. The exposed metal parts react with the acid. The plate is then cleaned of acid and wax. A decorative pattern is left on the metal plate. So in terms of the equation, this is what has happened. The dilute acid has reacted with the metal to produce salt and hydrogen gas. The second reaction that acid has is its reaction with carbonates. We can make use of the reaction of acids in substances in food preparation, such as in bread making. Baking powder is added to soured milk. This is added to the dough before baking Baking powder contains carbonate, while soured milk contains an acid. When the acid reacts with the carbonate, carbon dioxide is produced. The carbon dioxide produced is trapped as air bubbles in the dough. The bubbles of carbon dioxide expand during heating, causing the dough to rise. Let's look at the equation. When dilute acid reacts with carbonate, it produces a salt, carbon dioxide, and water. Now we look at alkalis. Alkalis are also found in many things around us. Alkali taste bitter and have a slippery feel. They are commonly found in soaps and liquid detergents. What are some examples of alkalines and their uses that you can think of? Well, there are some examples that I have with you. We have some detergent, laundry detergent, and hair dye. What are alkalis? Alkalis is a base that is soluble in water to produce hydroxide ions, OH-. Sodium hydroxide is used in making soaps and detergents. If you are curious, you can even go to the bathroom now and pause this video to check out the ingredients that is added into your soap and detergent. Ammonia solution is used to make fertilizers. Neutralization. When alkali react with acids, a chemical reaction called neutralization occurs. When alkaline reacts with acid, a salt is produced and water. What are some examples of neutralization reactions that you can think of? The toothpaste contains an alkali which reacts with acid formed when bacteria acts on food particles on our teeth. When the alkaline reacts with the acid on our teeth, salt and water are produced. The acid is neutralized by the alkaline to prevent tooth decay. Let's watch a video.
When you expose and pacifiers, you share bacteria that causes tooth decay in your child's mouth. These bacteria feed on sugar and weak behind acids that cause cavities, holes, and then decay. This salt is 100% preventable. Brush and floss twice a day to keep the cavities away. Moms, it's up to you. Healthy habits for a healthy smile.
You're watching SCI CODE. It's a known fact that everybody poops. We eat food to live, and we poop out the stuff that we don't need. Animals poop, people poop, and the bacteria in your mouth do the same thing. Seriously, our mouths are homes to billions of bacteria. They love to eat the same food that we do, and they especially love sugar. Candy! After you eat, your body excretes the stuff that you don't need, and bacteria do the same thing, but their poop is acid, and that acid can be potentially dangerous. When the acid combines with saliva and sugar, it can start to dissolve the enamel of your teeth, causing cavities and an unplanned trip to the dentist. While you can't get rid of all of the germs in your mouth, by brushing and flossing regularly and properly, you can bring down the amount of bacteria and their poop to a minimum. So remember, if you're not taking care of your teeth, then you truly have a dirty mouth. SCI CODE.
Now we have come to the end of this e-learning module. We hope that you have learned much. Do look at the Google form and answer those questions. Thank you.